Welcome to this special event. Today marks a very important day for our team of data science experts. After 6 years of concentrated effort, we're very proud to celebrate the release of Seldon Deploy 1.0. This product is a result of hard work by our team, our customers, and community. Despite the uncertainties and dangers over the last year, these people have pulled together to build something that's truly extraordinary. And we all remain dedicated to the same goal of making machine learning easier to deploy, manage, and understand. And we thank you all for helping us to achieve this milestone as we continue to meet the needs of organizations looking to shape the future faster by improving their MLOps capabilities. So what's the current state of play? Well, machine learning, as the name implies, is a learning process. Organizations are investing heavily in machine learning because of the significant advantages on offer. AI-powered businesses are growing 30% faster with 50% higher profit margins. But according to IDC, 47% of machine learning models never make their way to production. Companies need a more reliable method of turning machine learning models into profit. Otherwise, why invest? We see a few key reasons why the full potential of machine learning is not currently being reached. Many off-the-shelf platforms will not meet the strategic needs of your organization and will not have the flexibility you need for the future. Every business has their preferred tools and frameworks. Being forced into vendor-specific ecosystems locks organizations into a very specific way of doing things, limiting their options for the future. There are skills shortages, particularly for data scientists and deep tech experts who are in high demand. Building a world-class machine learning team is out of reach for most organizations, limiting what they can achieve. And we're seeing a new role emerge, the ML engineer, whose masters skills across data science and DevOps, an extremely rare combination. In fact, LinkedIn has identified ML engineers as the most sought-after role in 2021. The data science and DevOps teams are often disconnected, which means it takes too long for organizations to move the models out of R&D and into production. The Deloitte Tech Trends report found that 40% of models took over a month to make it to production. Finally, despite the industry desires to implement responsible machine learning with reduced bias, there are huge technical challenges to overcome. This is not just a problem for data science teams, but for companies as a whole. It's not easy to understand the internals of machine learning models or explain their results, especially for non-technical stakeholders. Existing code tends to be research grade. Although good for testing, it tends to be too brittle to use in production environments. If we didn't have to trade off between risk-based governance and efficient machine learning deployment, we could all achieve so much more. So we started Seldon in 2014. It started out as an end-to-end machine learning platform covering the development, training, testing, and deployment of machine learning models. But there were simply too many variables involved in building a high-quality platform that met the bespoke needs of every organization. So we refocused on developing a toolkit that would accelerate the deployment of machine learning models, reducing the input required from DevOps teams. Since the very first releases of our earliest products, we've been leveraging cloud-native technologies, which have gone on to become a mainstream trend. These tools have gone on to revolutionize the management of large-scale applications and are perfectly suited to providing fully configurable building blocks that can be used to deploy, manage, and monitor machine learning models in production. We first released our open-source model-serving platform, Seldon Core, in 2018, which is now in use by many thousands of organizations with over 1 million models deployed and over 100 code contributors. Over the last 2 years, we've raised over £10 million of venture capital funding to expand our team of researchers and engineers. They understand the theoretical and technical challenges that you face and build a set of tools to overcome them. We're dedicated to customer success, working with early adopters to refine our offering and to integrate with leading platforms such as Kubeflow and Red Hat OpenShift. And with our early adopter customers, we've proven the benefits of Seldon Deploy. For example, we've reduced project life cycles from months to days or even hours once it's integrated into your workflow. An early adopter in the Fortune 100 reported cost savings of tens of millions of pounds on their ML projects, and that's not taking into consideration the enormous value that the models bring to the business. Seldon has proven productivity gains of 92% for organizations deploying machine learning models. So, what's in it for you? The Seldon suite delivers benefits in 3 key areas. freedom, efficiency, and responsible machine learning. Seldon increases the freedom and flexibility of your ML operations in two ways. First, to make sure you can take advantage of your preferred tools, Seldon is fully platform agnostic and framework independent. This gives you full control and avoids vendor lock-in. Second, Seldon allows you to overcome skills shortages. No need to build a complex deployment stack in-house. Seldon takes care of that for you. You're free to deploy and manage models without having to source expensive specialists. Seldon also solves many of your efficiency headaches. In the AI-enabled business, the more you can reduce time to deploy, the faster you can realize value from it. Seldon shortens the gap between R&D and production, so you can deploy models up to 85% faster. The model management and monitoring tools give developers a faster feedback loop, so they can see how their models are performing. They can use these insights to iterate and improve their models using advanced experimentation techniques such as multi-arm bandits. With Seldon Deploy, responsible ML is not just an industry buzzword, it's an invaluable set of tools. As organizations scale up to hundreds or even thousands of models in production, all it takes is for one model to start behaving in a way that's detrimental to the business to cause reputation damage, financial loss, or even problems with regulators. Seldon reduces those risks to help you to deploy machine learning responsibly. You gain greater control of model management and monitoring. Factor in auditability and version control, and you have a 360-degree view of every model in production. Rollback functionality is included to better manage underperforming models or algorithms that are not performing as expected. You can see inside the black box with Alibi explainable AI algorithms to interpret and understand how models are performing and to support decision-making. Drift detection allows you to monitor model performance degradation over time. You can then use these insights to determine if the performance is within acceptable thresholds or if the model needs to be retrained. And finally, deeply integrated compliance capabilities allow you to keep models within risk parameters. This unique combination of tools provides everything your organization needs to manage the full life cycle of your machine learning models. In summary, Seldon Deploy solves your challenges around freedom, efficiency, and responsible machine learning. So now you've been introduced to Seldon Deploy 1.0, we'll move on to a panel of early adopters in the space to talk about the 2021 MLOps Landscape. And after that, our CTO, Clive Cox, will be running through a more detailed demonstration so you can see exactly how your machine learning strategy can benefit.
Welcome everyone. My name's John Byers and I'm a partner at Osborne Clarke, and I'm going to be moderating this session on the amazing machine learning operations landscape, MLOps, and I'm joined today by Sophie Watson from Red Hat, Errol Koolmeister from H&M, and Adrian Rossall from AstraZeneca. And they're going to introduce themselves very briefly, and then we're going to have a bit of a conversation about how they're seeing developments in the machine learning operations landscape. So over to you, Sophie, please, if you just explain to the audience a little bit about yourself and how you're involved in MLOps.
Thanks, John. Hi, I'm Sophie. I'm a data scientist at Red Hat. And over the past few years, I've really been focused on helping our customers put machine learning into production. We've been thinking about how we can get those machine learning workflows and workloads running on the hybrid cloud.
That's fantastic. Thank you very much, Sophie. And I'll just hand over briefly to Errol to explain a little bit about what he's doing with MLOps at the moment in the retail space. Errol.
Thank you so much, John. So Errol Koolmeister. Currently, I'm heading all the AI engineering areas within H&M Group. So data science, machine learning engineering, software engineering, and product development for all the different AI projects we have across the group. So when it comes to MLOps, it is my responsibility to create the setup around it, make sure we have the right prerequisite, and also focus on the value delivery aspect of putting models into production. We have a saying which is, we don't care how good your model is. If it's not in production and delivering value, it's not worth anything.
That's fantastic. Thank you very much, Errol. So now we're going to Sophie and I are going to have a bit of a chat about the MLOps landscape. And Errol, feel free to dive in if there are any observations you'd like to make. But Sophie, I'd just like to kick off with you first, and really to get a sense for the MLOps landscape. What is happening at the moment? What are the exciting areas in MLOps at the moment, from your perspective?
Well, I think according to the wider community, everything is exciting. If you say MLOps, then you're going to get your talk accepted to a conference, which is great. Everybody's interested and excited about this. I think MLOps is now seen as the minimal requirement for, putting a machine model into production. You need to have some MLOps going on in there so that you've got that trust, repeatability, and transparency into your model. I think that customers feel that MLOps is a way that they can start to see business value. And it's just really essential in order to have that structure and turn data scientists' work into something that we can really gain from.
That's interesting. I mean, I think one thing I find fascinating is that MLOps seems to be moving the whole machine learning sort of DevOps space into alignment with open source. And do you see that any issues as a data scientist with it sitting in an open source as opposed to a closed source space?
We're very much open source first and community first. So I think it's great that they're out there so that, everybody can access them and use them and understand what's happening. It's all about transparency, trust, and repeatability. So if they're not out in the open, then, do you really have that?
Yeah, no, exactly right. And what sort of techniques are there to verify the quality of those tools that are in those repositories, in those MLOps repositories? How do you know that when you're picking your MLOps model or tool that it's actually going to do what it says on the tin?
That's a great question. In practice, I go by strength in numbers. If other people have used it in the open source community, you get this constant feedback, right? You know what other people have used, what other people have tried and tested, and what other people are doing. Also at Red Hat, we're in kind of the unique position where we get to talk to a lot of our customers and see what they're doing as well. So we we know that somebody else used this worked well for them, this is something that we might be able to reapply elsewhere. I'm interested to know how Errol decides what's in and what's out.
Yeah, I mean, that's a really good question. Yeah.
And it is a good question, and it's a hard question as well. What we do is primarily look on a conceptual perspective. We have so many different projects going on all the time, so it's very hard for us to say exactly what to use. So what we do is that we conceptualize quite a lot. We try to understand the process as well. So MLOps is all for me around process understanding. How do you develop a model, and how do you then take that in from model development into production? One of the first things I realized in model development is that these are very different processes. One is very compute intense, and the other one usually have SLAs associated with it. So if you understand that process, you also then start understanding what underlying tools and technologies do I need in order to make that happen. What we do know, or at least state or think that we know, is that the entire MLOps space isn't done yet. It is in constant development. So for us, it's important to have an architecture from a technical point of view, which is very modular. So it's possible for us to change the building blocks of the tools and technologies that we're using. Because today we might have one tool and technology which we think is leading the race and it's very good for our architecture, but we know that tomorrow in this space something else is going to come there. So what we want to do is not always create best or state of the art. We want to create an architecture which makes it possible for us to be flexible in our infrastructure and our tools and technologies. So for us, it's a build-buy strategy. Of course, we know that we, as a large enterprise, we can't always be cutting edge because we have a lot of requirements when it comes, for instance, to stability. So if there is clear SLAs, clear proof of concept, clear support from a larger community, either commercial or non-commercial, it is very hard for us to actually incorporate that into our product roadmap on how to actually go ahead with MLOps. That's why I'm always having a hard time listening to pitches where somebody says in MLOps, I've sold it. I got the greatest product ever. I got all the pieces from development to deployment and to follow-up, because we're just not there yet. And that would then lock me into a product, which is very hard. I don't want that. I want the flexibility so that we constantly can improve the things that we're building.
Yeah, I mean, your answer raises a very interesting question, which I see in terms of the way the industry is progressing. And obviously it is a very new industry, and there are different routes to market. There are very big service providers such as Azure and AWS that are touting their own tools, and then there's a very vibrant MLOps landscape, which is allying itself to, as I discussed with Sophie, to the kind of open source side. Which side, I mean, I'll put this question to you both, which side of that market do you think is going to win? Because it's very interesting. I can see now, for example, Microsoft seeing that, or Azure seeing that, this is a good market, MLOps is a good market, maybe we should be moving away from classic AI as a service provision and into MLOps. What do you guys think about that question?
I certainly think that in the long term, the open source community will win the things that we can go and download and play with ourselves. That being said, I don't think it's bad that the cloud providers are moving into this space. I think anything we can do to get these models into production in a more robust way and with better practice is a good thing.
Errol, did you have any views on it?
Yeah, of course. I think that open source has already won. I think if you look on just a community and development, the tools and technologies coming out today and the ones that we trust are the open source ones. Having said that, open source by itself is not winning. But what I see is the combination between open source community development and access to technology and enterprise support, because I'm coming from the enterprise support angle. If I'm using a tool and technology and I can't get the support from a stable partner with a long-term relationship, I will be very hesitant to actually using that open source, because you don't know. Tomorrow that tool and technology might not be there and the community has abandoned it, because that also happens. You can see that on GitHub and all the open repositories. And I need that long-term commitment as well, which you can get from an enterprise who's actually is making money out of it. So it's the middle ground. And we have actually had dialogues with some of our partners and said, great technology, but you have to make it open source, then we're going to start using it. And it's actually happened, because when you put the requirements out there, things start moving in the right direction.
That is interesting. Yeah. I mean, the other issue that I think is probably worth exploring is, classic enterprise AI service provision, you just hand the whole thing off to a big service provider and they'll build it for you. Do you see the pipeline benefits, the speed, the reproducibility of machine learning ops as a bigger benefit than the overhead of employing lots of people to develop?
Well, I don't see them as mutually exclusive. So what we have done right now, and I'm sound like a politician here all the time, but what we have done right now is trying to find a middle ground, right? Because there are different advantages to the different approaches. One is kind of utilizing software pre-built from kind of a cloud vendor or a third-party provider that claim to be able to do AutoML and provision models that you can track and then just publish to an API. That's the one route. It has the benefits usually of the time to value is much shorter, but the total potential and the ownership is lower, I would say. So what we are exploring right now is both paths, because what we want to do is eat the cake and have it at the same time. So we're trying to provision a way for more citizen data scientists, data analysts that might not have access to all the tools and all the data engineering efforts that's required for building it ourselves, so they can actually get access to easier tooling and deploy and try it out and see if there's value. So proof of concept, proof of value, initial maybe API integrations. So then when we actually get to the large scale use cases that require us to build actual software from the ground up, we have the capabilities to focus on them. Because if you look on H&M and the global scale, we are in almost all the countries in the world. We have 5,000 stores, one of the largest online sites in the world for shopping. When we deploy to that, it needs to be configurable, it needs to be stable according to our requirements. And I would say it's always crucial that we own that IP as well. Of course, we're going to put bits and pieces from other providers, but owning at least the architecture and the delivery process is required, I would say.
Yeah, so scalability is clearly a huge part of your evaluation, and you can see that scalability in the MLOps side. Yeah, that's very interesting. Yeah. So if I was to ask you both of any specific use cases that you're able to talk about that you've come across in your MLOps careers, either at Red Hat or at H&M, because I'm sure the audience will be very interested to hear about those, to extrapolate them against their businesses. Could you give me a particular example where MLOps has provided a demonstrable benefit?
Yeah, I can start. So we do work with many customers that have models in production, but actually the majority of people we talk to are data scientists who their general job isn't to put a model into production. It's to perhaps, they're programming in Jupyter notebooks, on their laptop initially, in messy environments. And so something that we've really focused on is how can we make the standard data scientist who sits at their desk and does not push to production, how can we make their life better with MLOps? So we've been looking at workflows around that kind of earlier stage of the machine learning life cycle. So how can you repeatably test and deploy in Jupyter notebooks, which are, traditionally very messy. I don't know if you've ever used them before, but
I have, yes.
They can go wrong in many ways very easily. It's that classic case of it works on my computer, but it doesn't work on your computer when I send it to you, John. So I think something I've really enjoyed is thinking about how we can make Jupyter notebooks more repeatable and reproducible. Are there ways that we can take a Jupyter notebook, analyze it, and actually create a model service that exposes an API that we can interact with automatically? Essentially, I'm really focused on just helping those data scientists in their daily work. I know Errol's probably going to approach this from, the cool things in production standpoint, which is what everybody wants to hear. But in practice, I think our customers and our colleagues are in general not quite there yet with running big systems in production.
Yeah, that's really interesting, Sophie. Thanks. Errol, is there anything that you can pinpoint from an H&M perspective that the audience would be interested in?
Maybe I can tell you just shortly about our journey towards production as well. So some of the first use cases that we did, for instance, Markdown for our online business, was focused very much on getting into production. So just getting it there and getting some value. And for me, that's just the first step. You can do that in a couple of different ways. When you do it the first time, you tend to just focus on the value, just push it out there. I don't care how it's done, but at least we can act on the numbers. It's a very good approach just to prove the point. So that's the first step of most companies getting to production and getting some value. However, that builds a lot of technical depth as well, especially if you're going to scale it across the globe, because you're not doing repeatable processes, you're doing spaghetti code, you're having entangled notebooks, as I'm sure we are all aware of how tedious they can be, and you have a lot of engineering effort just putting it into production. So some of the first thing we started doing after doing that was just mapping out all the processes, making sure there was a common understanding what's the end-to-end process. How can we make those notebooks more repeatable? How can we put them into virtual environment? How can we standardize the process? How can we put pipelining into all of these things? And when they're in production, how do we have a good control measurement and follow-up process of these things? And then how can we automatically retrain and have an iterable process? And that's step 2 as I see it. The third step is the next step on the maturity curve is you've done that for one use case, potentially 2. How do you create a repeatable process for all of your coming use cases as well? So how do you make sure that the first time you might do this at scale, it might take a year and a half? How do you make sure the next time you do it, you can leverage all the learnings from the past, all the reusability aspect, so you get it down to potentially less than a year? And the third time, 6 months, and then you become better and better of understanding the process, and then you can get it down to a few weeks. And the only way of doing that is having proper machine learning ops, and it's a way of pinpointing the process, creating reusable aspects, making sure there are code libraries, everything can be reused and everything can be re-accessed, and everything is just smooth sailing. Infrastructure as a code. That's at least my vision of trying to do that. And I think we are on stage 2, entering stage 3 now at the H&M Group.
Oh, that's really interesting. Thank you. Now, I'm going to ask a question which, given that we're on a Seldon panel, won't come as a surprise to you. It's really just to get your sense of where you think Seldon is in the kind of the MLOps universe, how well you think it's positioned. It'd be interesting to get a sense for how you're using Seldon product in your MLOps delivery.
Of course, I'm a big fan of Seldon. I've been on the sidelines watching them for a long time now. Always try to find a good use case for it. Most of our initial use cases were batch oriented, so they work quite hard in the beginning to find a good fit. Now that we move more towards online, it has a perfect fit with what we want to try to achieve. So when we're serving high-level SLAs towards H&M.com, we're now also experimenting with utilizing Seldon in that kind of deployment process. The way they utilize the process makes it very easy for us to develop the models and productionalize them, making sure our models are containerized well, the process is well defined, making sure we have proper A/B testing, multivariate testing, in all of those things. So Seldon is, I would say, it fits very well into that ecosystem, and I would say it's the best technology that we've come across so far to be able to live up to our high standards.
Oh, fantastic. Sophie, did you have any views on it?
Yeah, I mean, when we've been using Seldon, certainly for all kind of experimentation and internal use cases, then it works as you expect it to, which is very nice. That's, the minimum of what you expect from a product, but it doesn't happen that often that things do work as they expect, especially not in the MLOps area where everything's so new and evolving. So that's really nice. But something that my team has really been focusing on and making the most of is the Seldon Alibi library. So this provides explainability and interpretability to those black box machine learning models. I think a lot of people want the insight into what is my model doing, how is it doing, and Seldon Alibi is just so simple to get those insights quickly and kind of for free, really.
Yeah, no, I mean, that's a really interesting point. I mean, you expect me to be a little bit geeky about the law because I'm a lawyer in the AI space, and actually explainability is a huge looming regulatory issue that is going to be coming down the pipe, particularly with the potential for a draft regulation on AI. The European Union's been talking about that for some time, so that's really interesting to hear.
Yeah, and we still have. Sorry, John.
We
still got many customers who are not able to move to using machine learning in production because of the regulations. So many people are still using business rules because of explainability purposes. So I think this is really a step in the right direction.
Yeah, no, that's really, really interesting to hear, actually. And what you're saying reflects precisely my experience. We have clients that would love to pick up machine learning, but simply can't do it because they're so heavily regulated. And there's a requirement for reproducibility, explainability in their technology, and they can't figure it out with machine learning. So it's much easier just to use traditional technology. So that's great. The other thing that I wanted to pick up with you both, and it comes through, I think, in kind of Errol's answers as well. Now, I find this quite interesting because I'm a service provision lawyer, so I like to see end-to-end service provision. I like to see end-to-end SLAs, and obviously, what's intriguing me about Errol's position is that you want the best of both worlds. You want to be able to pick and mix from the MLOps repositories, and you want supported SLAs on the tools that you select for your integrated solutions. How do you achieve end-to-end service provision and SLAs in what is essentially it is a bit of a fragmented landscape, isn't it? You've got to stitch different tools together.
Yeah, I mean, it really exacerbates all the problems, doesn't it? You've got no complete solution. You've got some bits of kind of self-written, self-supported glue code gluing things together. When we think about machine learning systems, we know that they're hard to manage, not because of the machine learning part itself, but because of the complex interactions between the machine learning and everything else going on in this intelligent application. And now we've got these MLOps systems and the individual components, they make sense, we know what they do, they might be supported, but it's the interactions between service A, MLOps service A, and MLOps service B and C and D that is just so complex. You sort of need meta MLOps for MLOps.
Wow. Well, we're getting into the realms of philosophy now, aren't we? Maybe that's the next challenge for Red Hat, which is very, very interesting. And I just wanted to, as a non-data scientist, but as a professional who works in this space, I just wanted to get your sense on how the MLOps ecosystem refreshes itself, because I work in a very conventional business sense, which is, you have enterprise that charges for a service and delivers that service, and that's how they make money. And what I see with MLOps, which is really interesting, is a lot of open source, very good open source tools that are put up in repositories, and it doesn't seem to be anything apart from the goodwill of those businesses that is driving the hosting of those tools. So how does the whole MLOps ecosystem work? Is that something that you can shed some light on?
I wish I knew how it works, but sometimes it feels like magic. But I mean, from my personal perspective, and being so tech geeky about these things, from my perspective, it's really about understanding and keeping your ear to the ground. There are a lot of services out there, open source repositories, that almost does the same thing. And what's important is always kind of understanding where they're going. Some are maturing faster, some goes up, you try them, they'll fade away. So I think there are some natural cycles in there. And I really like the natural cycles of the technology landscape in general. I mean, MLOps is one of those. I think that goes for DevOps in general, DataOps as well. But it's still about finding the best tools for your problem at this stage.
Yeah, it's a bit like a sort of machine learning evolutionary cycle, isn't it? It's the survival of the fittest. The best tools will survive. The tools that don't really work that well are just going to wither on the vine, aren't they?
Yeah. It's a trial and error.
Yeah, fantastic.
And I think we're lucky that everybody realizes that if you're putting machine learning into production, or you're just doing machine learning, you need to do it with trust and transparency. And so everybody knows that they need MLOps, and that's not going to change. So although these individual products may kind of have their life cycle, I think we're never going to be in the situation where we certainly don't have a solution in this area because of the amount of force behind this movement at the moment.
Sorry, Errol, were you about to say something?
Yeah, I think what I always listen for is more thought leadership around these topics. I mean, one of the reasons I actually started watching Seldon was because I thought a few years back that Seldon provided a lot around thought leadership, still do. And you see a few players in the market that actually provide thought leadership and pushes the technology landscape in the right direction. It doesn't happen often, but from time to time you have these companies, you have these presentations that see not only for their own good of their company, but also for the greater good of the technology community. That's why it's always so nice to interact with these type of players on the market, listen to presentations and see where we're going. I have no idea where we're going right now, but once you're out in the market listening in, you get an idea where we're going, and then you can start adopting it in your own business processes as well. So it's a constant evolution.
Well, that's really interesting. I mean, I think and that kind of leads into the next question I was going to ask you both, which is, for those of the members of the audience that are wondering about whether MLOps can bring demonstrable benefits, real benefits to their business, and are worrying about it, deciding which option to take, to take the plunge into machine learning, what can you say to convince them to go down the MLOps route?
Well, I want to look at research. And the closest thing that you can extrapolate from, I would say, is the State of the Art of DevOps report from 2019, where you actually map out, by utilizing these tools and technologies, not specifically MLOps, but more CI/CD processes, you'll see 3 to 5 more business value. And it's faster time to market as well for all your product development, and your team will become more efficient. So I usually use that as extrapolation to why you should go down that route. Creates consistency, creates faster time to market, more value in the end.
Yeah, I think on top of that, we've seen over the last 10, 15, 20 years how DevOps practices have completely benefited the standard software development life cycles. They've just come so far in that time. And why not apply that to machine learning? We have the same concerns there and more. And we have, practitioners that are perhaps, data scientists aren't release engineers. There's certainly a gap in the skill set there. Or you've got yourself some fabulous unicorn data scientists that you should give a pay rise and never fire. So I think that, we need this tooling in order to gain those benefits.
Yeah, I see it as it's really a path to maturity for the machine learning industry. If you take the equivalent of, say, ERP, enterprise resource planning, and CRM solutions, the likes of which used to be developed completely in-house and now are very much a commoditized marketplace. I see that's the way, from my non-data science perspective, that's the way I think the industry is moving. So I would agree with you both. It is heading towards maturity and self-selection, and MLOps is where it's at.
We've just started this journey, and I think many of the companies are going through some of the revelations I myself personally have done the last few years. I was fascinated with AI, machine learning, and all the value we could actually extract from the data for companies and for humanity at large. What I realized as well was the struggles I needed to go through to actually extract and get that value. Developing the model was the easy part, and I also have an engineering background. So I was so frustrated, and this was a few years back. So when we started to see the MLOps landscape appear, I was super happy for once, because I started seeing the benefits of actually utilizing these type of tools and technologies. But we're still early stages. There is, in my opinion, no end-to-end suite to solve all of these problems. I do believe we will see more and more solutions in the coming few years. But in order for us to reap the benefits already now, we need to start exploring. We need to listen to our engineers on how we put things into production. And we need to foster a co-creation between the data scientists and the engineers to make sure we actually get our models into production and we get the value out of it.
Yeah, you get the models that you actually need. Yeah. Sophie?
Yeah, those cross-functional, cross-team interactions and communications are so vital. I think I agree with Errol. It's still early days. Solutions are still being tried and tested, and I know it can be daunting to decide what to pick, but I think doing something is better than doing nothing. It helps you to figure out what you want or what you don't want in this space. Something that I think we're really missing is those higher level tools. I think we need to bring this back to the fact that data scientists aren't software engineers, are not release engineers. And so in order to really implement these MLOps best practices, we need those high level tools that have, an easy entry point so that we can reap the benefits.
Well, that's fantastic. And on that note, I wanted to thank you both very much indeed for what has been a very engaging conversation on MLOps. Thank you both. So I'm now joined by Adrian Rossall from AstraZeneca. Adrian, why don't you tell the audience a little bit about yourself before we start chatting about MLOps?
Yeah, I'm Adrian Rossall, and I lead the IT platform which is called Augmented Drug Design in AstraZeneca, which is really a new IT platform enabling better use of data and artificial intelligence, machine learning techniques to really try and accelerate drug discovery. And my background really is from the chemistry domain and drug discovery and pharmaceuticals, going back pretty much back to university. So really, it's quite an exciting journey we're on, and quite an exciting thing within AstraZeneca that we're bringing all of these technologies together to look at how we can make drug discovery faster and getting drugs to patients quicker.
And how specifically does MLOps enhance that drug discovery pipeline compared to standard technological techniques?
We in this kind of early drug discovery space that we're building this in and we're working in, we have to do we make a lot of compounds and have to go into a laboratory to measure a lot of properties and values, and really the more that we can do in computers, in silico, using machine learning techniques and other computational techniques, the less we have to do in the lab, and the faster that we can develop drugs, because we work out which ones we should make and which ones we should investigate further outside of the lab, and that's obviously saves a lot of time and ultimately money as well. But we want to bring the drug discovery cycle in this space is like 24 months, and we want to strip 12 months off that by using predictive modeling better, and that's our aim by 2025, which is definitely quite a big mission, and MLOps is really enabling us to scale up that capability to use predictive data, and we have had a past system in this space before, but it had limitations on the types of models we could deploy. It definitely had limitations on the scale that we could use it at, so we had to have defined limits.
Was that a bespoke system that AstraZeneca had developed itself, or was that third party system?
That was a bespoke system that we developed ourselves on a kind of a high performance compute platform that we had in his head. Yeah,
and tell me, because obviously when you're faced with the sweet shop of a repository with loads of MLOps tools, how does AstraZeneca select, in quality terms, the right tools for the right job? How do you go about selecting the right MLOps tools?
A lot of our modelling and predictions are obviously very, have to be scientifically aware and are very kind of industry specific. So we had to find a solution that supported that kind of level of customization that some of the kind of package solutions didn't always have. So we really want the flexibility and ability to use a lot of the open source scalability and the cloud technologies in collaboration with MLOps tooling for deploying models faster and monitoring them and retraining them and giving putting those really good quality predictive endpoints into all of our scientific applications that scientists use.
Yeah, I had an interesting discussion earlier with Errol, and we were talking about precisely this issue for H&M, obviously in a completely different industry, retail clothing industry. And I guess one of the issues that sprang to my mind, and I was quizzing Errol, and I'll ask you the same question so far as AstraZeneca is concerned, is how do you work to end-to-end SLAs, and if you do, how do you manage that? Because obviously when you're stitching together an MLOps solution, you're going to have a variety of different potentially open source tools that you're using. How do you get end-to-end accountability in terms of SLAs, or do you not worry about that?
We're working heavily in the research space, so there is a lot of we want to move fast and innovate. So we accept that in doing that, it may be that we've not got tight SLAs that a production platform might have that's maybe manufacturing a drug or such like. So we're really focused really early research, which gives us some flexibility. But also our IT platform approach that we're taking is we work directly with the business to develop these systems, and then we deliver the systems to them, and they consume them. So we've got that very much awareness of when we're moving fast, they know it, and when we want to have a stable system, we focus more on that.
Yeah, so you've got a tolerant internal client who recognises the benefits of using the solution. I completely get it. And in the context of the Seldon solution per se, why don't you tell us a little bit about how you're using Seldon and how that is helping your drug discovery pipeline specifically? So
it's about 2 years ago that we kind of started our journey of looking for a new predictive platform as part of our augmented drug design program, and we kind of scouted the market, and as I've mentioned, we need something flexible that we can put our customized, scientifically aware models into, and we were quite early on. We probably realised we want to use things like Kubernetes and cloud to do the scaling up and down and bring us that flexibility. And from that, we looked across what the offerings were, and Seldon gave us a lot of that. Basically leveraging a lot of the technologies that are out there, and then giving us that bit that we can't find elsewhere. So that whole deploying models faster and managing them in Kubernetes for our modeling endpoints, that we can then easily, flexibly plug into our applications. So from that journey a couple of years ago, we now have Seldon fully deployed and have all of our predictive models in drug discovery AZ kind of loaded in there. And we're really at the point where we're connecting into more and more applications and getting those predictive endpoints used by in as many places and by as many scientists as we can.
Good. So it's really helped to accelerate the whole pipeline activity. Yeah. And if you were to, and this is another question I put to the other two panelists, because obviously the whole machine learning AI market is nascent. It's growing rapidly, but it's bifurcating into what I would see two separate parts. So you've got the full managed service, artificial intelligence as a service, which is provided by the likes of Azure and AWS, and it's the full turnkey solution. And they're obviously plugging their closed source proprietary models and libraries. And then you've got the wonderful world of MLOps and the vibrancy of open source. Where do you think the market is heading? Just moving away from sort of drug discovery and just looking at top down at the whole kind of landscape for the machine learning market. Where do you think that's heading?
Well, I think it's worth saying our kind of philosophy is really to pick the best and use the best systems we can in order to accelerate our processes. So we probably we do that within the scientific domain, and the tools that we use in that domain, and I think that extends into the the ML AI machine learning space, in that we won't necessarily exclusively use one system, but perhaps of those two options we might use a bit of one and a bit of the other, depending on how it works, and as well as deploy models well, we need to make sure that people can build them easily so we can get the best value out of those models. So really I think a bit more pick and mix style, we choose the right solution for the right problem, which is...
Yeah, I mean, I think this is pretty much echoed by Errol and Sophie. I think this idea of having commoditized self-service type tools is actually the one that was the consensus from the other two panelists, is going to dominate the market. And what's really interesting is if you look at the big players like Azure, they're starting to drop stuff into MLOps repositories. They're starting to participate in that community, which would tend to indicate to me that they're betting their money on that side rather than on the full service sort of AI as a service side. That's great. And one question I did ask the other panelists as well was if you were to pick on a specific example where AstraZeneca has been assisted by MLOps, obviously without going into your confidential research areas, is there something that you could highlight to the audience? Because obviously people like to grasp on real examples to drive their thinking.
I think one of the ones that is fairly public, and one of the ones that we're working in collaboration with other people on is how we use predictions on how we should make molecules, so synthesis predictions, so that scientists don't have to work out how they might make a molecule. A deep learning machine learning model actually tells them, here's from past data, this is a suggestion of how you should do it. This is and with various scores that the scientists can use to decide whether to follow that technique. I think that's one of the examples where it really kind of adds value.
That's fantastic. And finally, do you see evidence that the other big pharma companies are diving in to the extent that AstraZeneca is diving into in MLOps? Is that, or is it something that is a unique decision on AstraZeneca's side?
No, I think the whole pharmaceutical industry is very much focused on how we can use our data better to develop drugs faster and get drugs to patients quicker. So I think we're definitely not alone, and there are collaborations that we're a part of with other companies on how we can collectively use our data better in the machine learning space. So it's definitely a big space for pharmaceuticals companies, I think. Yeah.
So you're all in the race together. Well, I'm sure Seldon will be delighted to hear that. So, Adrian, I want to thank you very much for participating in this discussion. I'm sure the audience will find it fascinating. Thanks very much indeed.
Thank you very much.
And now over to our CTO, Clive Cox, who will give a detailed demonstration of what's on offer in Seldon Deploy 1.0.
Hi, I'm Clive, I'm CTO of Seldon. I'm going to discuss some of the key technical aspects of the Seldon Deploy platform and how it helps to increase flexibility, save time, and reduce risk in your machine learning environment. We focus on Kubernetes as the core cloud-native technology to allow our customers to deploy their models either on-prem or in the cloud and scale to clusters of many thousands of compute nodes with shared GPUs and other resources. And we make that process as fast as possible. Seldon Deploy makes extensive use of a range of core cloud-native projects such as Prometheus, Elasticsearch, Knative, and Istio to provide a flexible, production-ready stack for deploying your machine learning models. Our technology teams have deep experience of the core research topics of model monitoring and explanations, as well as the core infrastructure challenges of scalable deployment architectures on Kubernetes. Deploying a machine learning model is more than just providing scalable model servers and APIs exposed for predictions. To have a true production-ready model, you need to add appropriate logging and data science monitoring to help understand your model is behaving and to contain risk. And now I'm going to go through some of the key components to serving models and discuss what is available in Seldon Deploy. The deployment wizard in Seldon Deploy takes you through the key choices for launching your model quickly. With Seldon Deploy, you can choose to launch your model in a native or serverless fashion onto a Kubernetes cluster. Seldon provides optimized servers for model artifacts which cover a range of common standards, including TensorFlow, scikit-learn, XGBoost, MLflow, along with Onyx, PyTorch, and TensorRT for use with NVIDIA Triton Inference Server. You can choose how your model will autoscale, with Kubernetes HPA management for native deployments with Seldon Core. Alternatively, choose min-max replica settings with your use with Knative via Care Serving to autoscale your deployments on demand. Seldon supports a broad range of technologies and standards to provide a flexible suite of tools that accelerate your deployments. Seldon Core also allows you to build up entire inference graphs made up of models and other components such as custom routing and ensembling. Using the wizard, you can add pre- and post-transformation elements to perform operations on the inputs before they reach your model and on the raw predictions after they return from your model. Another key component we provide is logging, so you can provide to push your request and response payloads to Elasticsearch. They can easily be queried from the deploy UI when the model is running. Finally, Seldon provides integration for GitOps, where every infrastructure action is stored in source control to allow full auditing and safe rollback, which will help decrease the risk of model updates. As part of the deployment process, you can attach documentation to be associated with this deployment. Once your model has been deployed, you can choose to query it and start load tests before your customers integrate via REST and gRPC APIs. As your data science team provide improved versions of the model, a key aspect is the ability to safely update your running model with a new version. Seldon provides various strategies for doing this, which include canaries and shadows. Canaries allow you to test a new challenger model with a small amount of traffic and slowly increase that traffic over time. You can de-risk the deployment process by ensuring that everything works as expected without affecting operations. In future versions of Deploy, we will introduce automation for this via progressive rollouts, allowing teams to create experiment strategies to move their challenger models more quickly for a series of tests before they are promoted as the new model. We also provide shadows, which allow 100% of the traffic to be sent to the new model, with only the response from the existing model returned to the client. This allows challenger models to be run with production traffic to allow metrics and checks to be run on the model. If the customer is using GitOps, then you can also have access to the full history of all updates and actions, and therefore rollback can be done to any previous version. This also offers an audit trail to show all actions that were done on this deployment over time. By using these techniques to update your model, Seldon Deploy allows you to increase the efficiency of putting machine learning models into production. Once your model is running, your team needs to monitor it closely to validate its operation. Seldon provides extensive functionalities for detailed monitoring. Our open source Alibi Detect library provides state-of-the-art monitoring capabilities for detecting outlier requests. Alibi Detect provides a range of techniques which focus on the different modalities of your model, including whether the input data is tabular, time series, images, or text, including special options for tabular data if you have categorical features. Saved outlier detectors can be added to your model infrastructure on demand and visualized in real time. A second key area of monitoring is drift detection. You need to know when to retrain your model as the input data distribution has changed or you're observing changes in the output predictions. Using a simple interface, you can add a range of drift detectors to your model as provided by our Alibi Detect library. Finally, if you have feedback on the correctness of the predictions of your model, these can be sent to Seldon Deploy to allow those data science metrics on accuracy and true false positive rates to be visualized in the UI. Added to this, we provide access to all the logs and core metrics of the containers running your model in the Kubernetes cluster. Monitoring is designed to be simple to implement and manage, reducing workloads for both data science and DevOps teams so they can focus on the other important tasks like building and deploying the next model. A key requirement to put complex machine learning models into production is to ensure models are launched in a responsible manner, where all stakeholders have an understanding of how those models are behaving for various input data types. Our Alibi product exposes a range of state-of-the-art explanation techniques, including anchors, counterfactuals, kernel and tree trap, accumulated local effects, and integrated gradients. These techniques can be applied as needed to provide insight into the running models. Finally, there are many other aspects of the deploy I have not detailed, including key enterprise features such as multi-tenant, multi-model usage, and integration into auth providers such as Keycloak and Dex. Furthermore, we provide both batch and streaming interfaces to your model so they can be queried as needed for different use cases. I hope I've given you a brief glimpse into Seldon Deploy and its capabilities, and I look forward to talking more with you and discussing how Seldon can help you achieve your goals with machine learning.
Thank you for joining us at this launch of Seldon Deploy 1.0. We're incredibly proud of what we've built, and we can't wait to see what you will achieve with this technology. Visit this link to request a free trial of Seldon Deploy. Thank you, and stay safe.